The last day to take the 50% gold test is Wednesday, which is, and it ends, as you can see here, at 11:59. But if you have, right now, if I were a student, I'm not ready to take it because my 50% progress starts at 79%. And if you go, how did I get to this page? I click these bars and I clicked assignments, and then it shows you where you are. So 50% progress is where I need to work. And so I would just click that and just try to finish these up. All right, so let me get out of this though. What I want to do is also show you that, let me go back to assignments. The 50% gold test is, I took the lock off of it. You see how these say schedule, lockdown, browser, and webcam? Some of the students were having issues and couldn't get into the 25%. So I gave them some extra time. They have till today to actually finish that particular test. But the gold test, all you have to do now is just click it and then just start. All right. So there's no lockdown or anything, but do not start unless your Pi progress is 100%. If it's not 100% on Wednesday, you have to take it no matter what. Or if the time runs out on you, then what am I pointing down here for? If the time runs out on you, oh, it says 12 a.m. If the time runs out on you, it runs out, and no, 11:59 right here. I see it. All right, so I just wanted to bring that to your attention. Now, the other thing is report. According to where the class is showing that only 44% of the people are getting these topics right here, like introduction to properties of addition. So I'm going to go ahead and go over that. And please stop me if you have a question. Let me click this down so I can have something to write with. Okay, so this is one of those situations where you got to know the definition of these properties. Now I'm going to tell you that, okay. So right here, this is a situation where the parentheses change. All right, so the numbers are the same. So this is 5, 2, and a blank. And over here we see 5, 2, 4. I need to put a 4 there. And then the only thing that's different is that in the first section, 5, 2, the parenthesis is on 5, 2. And then in the on the other side of the equal sign, the parenthesis on 5, 4. Bottom line is, it doesn't matter when you have all plus signals. This is the addition rule. It doesn't matter where your parentheses are, because everything is plus, it's going to equal the sign. 5 plus 2 is 7, and 7 plus 4 is 11. All right, and then over here, 2 plus 4 is 6, and 5 plus 6 is also 11. Why did I put a 1 up there? So with addition, you can move your parentheses around, and the work doesn't change. So this is the addition property. I'm going to put add property, and I'm going to show you the answer on the next screen. Right here, it says 0 plus some number equals 9. Well, we know there has to be 9. Well, and basically what this is saying is that I can have any number, and if I'm adding 0 to it, that number doesn't change. So this is the 0. I don't think it says 0. I think it says identity property. 0 identity. Or just identity. We're going to see it in a minute. And then 2 plus 7 equals 7 plus 2. When all you're doing is just flip-flopping the numbers around, this is called the commutative property. The commutative property. So that's just switching numbers around. Commutative. Spell that right. All right, so addition property, moving, everything is added, and you have more than 2 numbers that you're adding. The commutative property, there's only 2 numbers. And of course, the identity is just 0. So you're like, what are you talking about? Let me show you the explanation. Okay, so it says, oh, I said addition property. It's associative property. 5 plus 2 plus 4 equals 5 plus 2 plus 4. I knew it was something that began with an A. Associative property. And then, yeah, identity property for when you're adding something to 0, and commutative property when you're adding something, when you're just changing the numbers. And all of this deals with addition. Okay, so don't get it twisted with subtraction. Let me give you another one. Let's show another problem. So basically up here, we know we got to do 0. So that's the ID property, identity. That D looks wicked. That's a D. 5, 6, 4. So this has to be a 5. When I move parentheses around, that's that associative. And put ASSOC. And then, of course, the last one, 9 plus 7, 7 plus 9, is your commutative. So once you do a couple of these, you'll get to you'll get used to it, because they're just going to keep showing you the same stuff over and over. And as you can see, identity, associative, commutative. All right. That's the first one that a lot of students are having issues with. The next one is writing a mixed number and an improper fraction from a shaded region. I was wondering when this was going to pop up. Every class, we have students that have issues here. Okay. Yes, this is my favorite. Okay, so it says each circle counts as a whole. And so a mixed number is writing something like 1 and 1/2. This is mixed. All right. Well, if I was going to write this as a mixed number, if this is a whole, that's 1, 2, 3, and this little piece. Well, how do I know what that is? I have to look at the fraction. And so when I say fraction, I'm meaning, what are the cuts? How is this circle even cut up? 1, 2, 3, 4, 5. This is the way this circle is divided. So that means it's going to have a division of 5 on the bottom. How many are shaded within that circle? 1. So this circle right here represents 1 out of 5. And since I have 3 whole ones shaded, my mixed number is 3 and 1/5. So I hope this is the part right here that everybody gets confused. How do I know how to shade this? Well, it makes sense if you say 1 out of 5. But then now here comes the improper fraction. How many 5? I have 5 cuts in each one of these circles. So if I were only going to count the shaded parts, this is 5, 10, 15, plus 1 more. So I have a total of 16 out of 5 cuts. So basically this mixed number and this fraction, it's the improper fraction. It's the same thing. It's improper because you could do division here. 5 goes into 16 3 times. So if you do, okay, wrong. 5 goes into 16. 5 goes into 16 3 times. 3 times 5 is 15. And I have 1 remainder. That's where this thing comes in. 1 left over, 1 out of 5 cuts. Okay. Now they show you in the explanation, they show you that there are 3 wholes and 1 out of 5. So they did the same thing I did. Yeah, and then here they just counted them up separately. And since they are all cut into 5 pieces, the way that it's cut is always going to be your bottom number. Okay, so let me do another one. Just because sometimes it doesn't come in circles. Sometimes it comes Well, dang, there's another circle. So it is 1, 2, let me just put my marks here. 1, 2, 3. So this is 5 cuts again. And I have 1 whole one and 3 are shaded. So that's 3 out of 5. That's my mixed number. And then my improper fraction would be, this is a total of 5, 6, 7, 8. My other number would be 8 out of 5 for my improper fraction. All right. Okay, so let's go to the next problem. Classifying scaling, isosceles. Okay, yeah, this is geometry. Okay, so the first thing you need to know are the definitions. Isosceles, let's go with scaling. Scaling means all sides are different. So basically, if I see all the numbers are different and all angles, not just sides, I'm going to put angles too. Angles too. All right, so all of these are the same. 1, 2. I said there's 3 different. So this is definitely scaling. This they have 2 8s, so that doesn't count as scaling. All right, so that's scaling. Everything is different. Angles are different. Numbers are different. The other thing we need to know is isosceles. Oops, move this over. Can I get this? Okay, there we go. Oh my Lord. Let's just forget that. Okay, isosceles means at least 2 sides are the same. Isosceles. Wait, is that the way you spell that? Yeah. Isosceles. 2 sides are the same and 2 angles. Okay, let's put the E on the end. 2 sides and 2 angles are the same. So this, because it has 2 sides, that will be considered isosceles. We know this one is scaling. 1, 2, 3. Now this one, this trippy. You may think that this is not isosceles, but don't you see 2 angles that are the same? Yes, we do. These 2 angles are the same. Even though all 3 are the same, 2 of them are still the same. So this is considered isosceles. But the third one is equilateral. Let's change the color. Equilateral. Equilateral has 3 equal sides. 3 equal sides. Sides and angles. And angles. All right, so in this situation, this is isosceles, but it's also equilateral. So a lot of times when you have something like this, if you have all 3 sides the same, then you definitely have isosceles equilateral. But right here, we didn't have 3 equal sides, so this can only be isosceles. All right, and then of course they show you the explanations here. It says, so the triangle is equilateral. At least 2 angles have the same measure, so the triangle is also isosceles. This is the same thing here. This is only isosceles. Okay, so let's go to a different problem. Let's see, show me another one. All right, all 3 the same, isosceles equilateral. Just 2 are the same, isosceles. All 3 the same, isosceles equilateral. Everything's different, scaling. Easy peasy. You just keep that going. New problem. Okay. All 3 are different, scaling. All 3 the same, isosceles equilateral. 1, 2, only 2 are the same. That's isosceles.